Feeder cable can be used for branch circuits that feed remote pedestals. In addition to using feeder for branch circuits to pedestals, you can also use it inside an enclosure for jumper connections from each of the main service disconnects back to the current transformer, or CT can. Given a maximum length of 3 feet for the jumpers, this application is generally acceptable provided all connections are made properly and the installation adheres strictly to the National Electrical Code, or NEC, and any relevant local electrical codes. When using feeder cable for this purpose, several factors must be considered to ensure safety and compliance. Firstly, you must verify that the feeder cable is appropriately sized for the load it will carry. This involves calculating the total current demand of the pedestal or the equipment being fed from the disconnects, and then selecting a cable gauge that can safely handle that current. The NEC provides tables, such as Table 310.15b16, that specify the ampacity of different conductor sizes based on their insulation type and operating temperature. Ensure that the selected cable has an ampacity rate equal to or greater than the calculated load current. Secondly, the feeder cable must be properly protected against overcurrent. This is typically achieved by installing circuit breakers or fuses at the service panel or disconnect that are sized appropriately for the cable's ampacity. The overcurrent protection device should trip or blow if the current exceeds the cable's rating, preventing overheating and potential fire hazards. The NEC specifies the rules for overcurrent protection in Article 240. Thirdly, ensure that all connections are made using approved connectors and terminations. The connectors must be rated for the size and type of cable being used, and they must be installed according to the manufacturer's instructions. Proper termination is crucial to prevent loose connections, which can cause arcing, overheating, and equipment failure. Use appropriate torque settings when tightening connectors, and inspect connections regularly to ensure they remain tight. Fourthly, grounding and bonding are essential for safety. The feeder cable must include an equipment grounding conductor that is properly connected to the grounding system at both the service panel and the pedestal or disconnect. This grounding conductor provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Bonding is also important to ensure that all metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. The NEC specifies the requirements for grounding and bonding in Article 250. Fifthly, consider the environmental conditions in which the feeder cable will be installed. If the cable will be exposed to moisture, chemicals, or extreme temperatures, choose a cable with an appropriate insulation type and jacket material that can withstand these conditions. For example, underground feeder or AF cable is designed for direct burial and can withstand moisture and soil conditions. Similarly, THHN or THWN conductors are commonly used in conduit for their heat and moisture resistance. Sixthly, ensure that the installation complies with all applicable codes and standards. The NEC is the primary electrical code in the United States, but local jurisdictions may have additional requirements or amendments. Obtain the necessary permits and inspections to ensure that the installation meets all applicable regulations. Failure to comply with codes can result in fines, delays, and potential safety hazards. Seventhly, when running feeder cable inside enclosures, maintain adequate spacing between conductors and equipment. Avoid overcrowding the enclosure, as this can restrict airflow and cause overheating. Follow the NEC guidelines for conductor spacing and bending radii to ensure that the cable is not damaged during installation or operation. Eighthly, label all conductors and equipment clearly. Use permanent labels to identify the function and voltage of each conductor, as well as the rating of the overcurrent protection devices. Clear labeling makes it easier to troubleshoot problems and perform maintenance safely. Ninthly, regularly inspect the feeder cable and connections for signs of damage or deterioration. Look for cracks, abrasions, or discoloration in the insulation, as well as loose or corroded connections. Replace any damaged cable or components immediately to prevent safety hazards. Tenthly, consider using a qualified electrician to perform the installation. Electrical work can be dangerous if not done properly, and a qualified electrician has the knowledge, skills, and experience to ensure that the installation is safe and compliant with all applicable codes and standards. Using feeder cable for branch circuits, pedestals, and jumper connections inside enclosures can be a cost-effective and efficient solution, but it is essential to follow all applicable codes and standards to ensure safety and reliability. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.